Welcome to Metrology lecture series. In the present video, we will discuss the example problem on limits, fits and the tolerances. Let's see the problem. A clearance fit has to be provided for a shaft and bearing assembly having a diameter of 40 mm. Tolerances on hole and shaft are 0.006 and 0.004 mm respectively. The tolerances are disposed unilaterally if an allowance of 0.002 mm is provided. Find the limits of size for hole and shaft when hole basis system and the shaft basis system are used. Let's see the solution. So first we have to write down the given data. So here it is given the type of fit is the clearance fit and given the basic size is the 40 mm and tolerance is also given. So tolerance on the hole is 0.006 mm and tolerance on the shaft is 0.004 mm and tolerance is unilateral system. And also given the allowance is the 0.002 mm. So then we have to find the limits of sizes for hole and the shaft. That is, we have to determine the upper limit of the hole, lower limit of the hole, upper limit of the shaft and the lower limit of the shaft. So first we have to find these limits of the size based on the hole basis system. And we know that in the hole basis system, hole is kept constant and the shaft size is varying based on the type of fit. Moreover, in the hole basis system, the lower limit of the hole is the same as the basic size. So in the hole basis system, the lower limit of the hole is the same as the basic size. So here basic size is the 40 mm, then lower limit of the hole equal to the 40 mm. So next we have to find out the upper limit of the hole. For this one I have to use the tolerance on the hole. We know that the tolerance equal to upper limit of the hole minus lower limit of the hole. So here it is given the tolerance on the hole it is given and we know the lower limit of the hole. Then we determine the upper limit of the hole equal to the tolerance plus lower limit of the hole, which is equal to the upper limit of the hole equal to 0.006 plus 40. It is equal to the 40.006 mm. So we determine the upper limit of the hole as well as lower limit of the hole. So we determine the sizes for the hole. Next we determine the sizes of the shaft. For this one I have to use the allowance. So in the data it is given the allowance value is 0.002 and we know the allowance equal to the lower limit of the hole minus upper limit of the shaft. So we know the allowance value and also we know the lower limit of the hole also we know. Then upper limit of the shaft will become the lower limit of the hole minus allowance, which is equal to the upper limit of the shaft equal to 40 minus 0.002, that is the 39.998 mm. So next we determine the lower limit of the shaft. For this one I have to use the tolerance on the shaft. So tolerance on the shaft equal to the upper limit of the shaft minus lower limit of the shaft. We know the tolerance on the shaft and the upper limit of the shaft. Then lower limit of the shaft equal to the upper limit of the shaft minus tolerance, which is equal to lower limit of the shaft equal to 39.998 minus 0.004, which is equal to the 39.994 mm. So in the hole basis system, lower limit of the hole is the 40 mm, upper limit of the hole is the 40.006 mm. And upper limit of the shaft equal to the 39.998 and the lower limit of the shaft is the 39.994. Next we determine the limits of size for the hole and the shaft based on the shaft basis system. We know that in the shaft basis system, shaft size is kept constant and the hole size is varying based on the type of fit. Moreover, in the shaft basis system, upper limit of the shaft is the same as the basic size. So in the shaft basis system, upper limit of the shaft is the same as the basic size. In the data it is given the basic size is the 40 mm. Then the upper limit of the shaft equal to 40 mm. Then we determine the lower limit of the shaft. So for this one I have to use the tolerance on the shaft. So we know that tolerance on the shaft equal to upper limit of the shaft minus lower limit of the shaft. We know the tolerance on the shaft and also we know the upper limit of the shaft. Then lower limit of the shaft will become the, so lower limit of the shaft equal to upper limit of the shaft minus tolerance on the shaft. That is lower limit of the shaft equal to 40 minus 0.004, which is equal to 39.996 mm. So in the shaft basis system, upper limit of the shaft equal to 40 mm and lower limit of the shaft is the 39.996 mm. Next we determine the limit of sizes for the shaft. For this we have to use the allowance value. In the data it is given the allowance equal to 0.002 mm and we know that allowance equal to lower limit of the hole minus upper limit of the shaft. So we know the allowance value and also we know the upper limit of the shaft. Then lower limit of the hole will become the upper limit of the shaft plus allowance. Then lower limit of the hole equal to 40 plus 0.002, which is equal to 40.002 mm. Next we determine the upper limit of the hole. For this we have to use the tolerance on the hole. So tolerance on the hole equal to the upper limit of the hole minus lower limit of the hole. We know the tolerance on the hole and also we know the lower limit of the hole. Then the upper limit of the hole will become the tolerance plus lower limit of the hole. Then upper limit of the hole will become the 0.006 plus 40.002, which is equal to the 40.008 mm. So limit of sizes for the hole or the lower limit of the hole is 40.002 mm and upper limit of the hole is the 40.008 mm. So based on the shaft basis, the limits of sizes for hole and shaft are the upper limit of the shaft is 40 mm and lower limit of the shaft is 39.996 mm. Similarly, lower limit of the hole is 40.002 mm and upper limit of the hole is 40.008 mm. So then we represent these limits of sizes for the hole and shaft by the schematically by the for the hole basis system as well as the shaft basis system. So this is the schematic representation of the limits of sizes for the hole as well as the shaft. So by the hole basis system, and similarly this is the schematic representation of the limits of sizes for the hole and shaft by the shaft basis system. So this is the solution and thank you.